Analytical techniques are fundamental tools in management accounting for estimating future costs, revenues, and resource requirements. Budgeting and forecasting rely heavily on statistical methods that analyze historical data to predict future behavior under varying business conditions. These techniques assist managers in planning production, estimating costs, allocating resources, evaluating alternatives, and reducing uncertainty in decision-making. Among the most widely applied methods are linear functions, high-low analysis, scatter diagrams, regression analysis, correlation analysis, and price adjustment techniques, all of which provide quantitative support for managerial planning and control. A linear function expresses the relationship between a dependent variable and an independent variable through a straight-line equation of the form y equals a plus bx, where y represents the total cost or revenue, a represents the fixed component, b represents the variable cost or revenue per unit of activity, and x represents the activity level, such as production units or machine hours. This equation assumes that costs change proportionally with activity within a relevant range and forms the basis of many budgeting and forecasting models. Once the values of A and B have been estimated, managers can predict future costs or revenues at different activity levels with reasonable accuracy. One of the simplest methods for estimating a linear cost function is the high-low method. This technique separates total cost into fixed and variable elements by selecting the highest and lowest activity observations from historical data. The variable cost per unit is calculated by dividing the difference in total cost by the difference in activity levels. The fixed cost is then determined by subtracting total variable cost from total cost at either the high or low activity level. The resulting cost equation can subsequently be used to estimate costs at alternative production levels. High-low analysis may also be applied where costs contain semi-variable components, separating mixed costs into fixed and variable portions. Where stepped fixed costs exist, or the variable cost per unit changes across activity ranges, the analysis should be applied separately to each relevant range to maintain accuracy. The high-low method offers several advantages. It is straightforward, inexpensive, and requires only 2 observations, making it suitable when limited historical data are available. It provides a rapid approximation of cost behavior and can be easily applied in budgeting and short-term forecasting. However, the method also possesses significant limitations. Because only 2 data points are used, the estimates may be distorted by abnormal observations or unusual operating conditions. The technique ignores intermediate observations and assumes a perfectly linear relationship, which may not reflect actual business conditions where economies of scale or operational inefficiencies exist. Consequently, high-low analysis should be regarded as an approximate estimation tool rather than a precise forecasting method. A more comprehensive visual approach to analyzing cost behavior involves the use of scatter diagrams. A scatter diagram plots individual observations of cost against activity levels, enabling managers to observe the relationship between variables. If the plotted points cluster closely around an upward-sloping line, a positive relationship exists between activity and cost. Conversely, a downward trend indicates a negative relationship, while random dispersion suggests little or no correlation. A line of best fit may then be drawn through the observations to represent the underlying linear relationship and estimate the cost function visually. Scatter diagrams are particularly valuable for identifying outliers, unusual observations, and nonlinear patterns before statistical analysis is undertaken. The strength of the relationship between 2 variables is measured by the correlation coefficient, R, which ranges between -1 and +1. A value close to +1 indicates a strong positive relationship, where increases in activity are associated with increases in cost or revenue. A value close to -1 indicates a strong negative relationship, while a value near 0 suggests little or no linear association. The coefficient of determination, R superscript 2, measures the proportion of variation in the dependent variable explained by changes in the independent variable. For example, if R equals 0.90, then R superscript 2 equals 0.81, meaning that 81% of the variation in costs is explained by changes in activity levels, while the remaining 19% results from other factors or random variation. Regression analysis provides a more sophisticated statistical method for estimating the linear function by utilizing all available observations rather than only 2 points. The technique calculates the values of the intercept A and slope B that minimize forecasting errors and produce the best-fitting linear equation. Once established, the regression equation can be used to forecast future costs and revenues at expected activity levels, supporting budgeting, pricing, and capacity planning decisions. Regression forecasts are generally more reliable than high-low estimates because they incorporate the complete data set and reduce the influence of random fluctuations. Forecasting frequently requires adjustment for price movements to ensure that historical data remain relevant. Historical costs may be converted into current price levels by applying inflation indices or forecast inflation rates before future budgets are prepared. Such adjustments distinguish changes arising from inflation from those caused by operational efficiency or volume changes, improving the reliability of cost projections and long-term financial planning. Despite its superior accuracy, linear regression analysis also has limitations. It assumes that relationships remain linear and stable over time, whereas actual business environments may change because of technology, capacity constraints, or market conditions. Regression models are sensitive to extreme observations and require sufficient historical data to produce reliable estimates. Furthermore, statistical relationships indicate association rather than causation and should therefore be interpreted alongside managerial judgment and qualitative business information. When appropriately applied, however, analytical forecasting techniques provide an indispensable foundation for evidence-based budgeting, planning, and strategic decision-making in management accounting.